I'm going to show you how to check a piece for squareness or perpendicularity. This tool right here is called a compound angle block, and basically it's got a 90-degree angle from the base to this surface, a 90-degree angle from here to there, 90-degree angle between this face and this face. This face is also perpendicular or at a 90-degree angle to the surface that the thing is clamped down to, as well as this one. So if I take a workpiece such as this one and I place it in this angle plate, and you notice I had a steel ball. It's out of an old ball bearing. Basically that allows the piece that I'm checking to rest on a single point on the surface of the ball, so I don't introduce any error in the reading, that might happen if it was sitting on a flat surface. But anyway, basically now just set the dial indicator to 0 at some point on the surface of the piece and move it around over the entire surface to check for variation from that 0. So I'm seeing, if I'm dead 0 at that corner, I have to repeat, don't I? I'm going to zoom in a little bit so you can see a little bit better what we got. 0 at that point. When I come out to here, it's plus 3/10 of a thousandth, back to minus 2/10, minus 3/10 there. I'll 0 it there. Come on and off a couple times just to make sure I'm repeating my 0 to here, and plus 6/10 of a thousandth over here, plus 7/10 of a thousandth, back to plus 3/10, and then back to 0 here. So the total, that surface lies within a tolerance zone, a total variation from perfect perpendicularity of 7/10,000ths of an inch, or 7/10 of a thousandth, as the machinist or a toolmaker would say. So again, this is a compound angle plate resting on granite surface plate, which is flat, basically within 40 millionths of an inch over its entire surface. I believe it's 18 by 24 inches, so you can get a lot of area you can use for checking parts on the thing. There you have it. That's a setup for checking perpendicularity.